Hi, everybody. This is Chris West from House Calls Vermont, and we're here with another interview. Today, we have the good fortune of having a colleague of ours, John Rockwell from Zehnder America. John, welcome to House Calls Vermont. Thanks for taking time out to meet with us.
Thank you, Chris. It's a pleasure to be here. Thanks for asking me.
Great. So, we do a series of interviews. We interview people from all different parts of the industry, and of course, Zehnder is a company that makes ventilation systems, heat recovery ventilation systems, and also enthalpy or energy recovery systems. Everything from the box that does all the work to the tubes and plenums and everything from large systems, and I think Zehnder is, correct me if I'm wrong, pretty much specifically just residential. You guys top out at the CA 500 or the 550, right?
So Zehnder America does top out at a unit that does a maximum of about 325 CFM in a boost mode. Um, Internationally, the Zehnder Group offers rooftop units that you see on large commercial buildings up to 8,000 CFM, something like that. So that's not the model we're pursuing here. It's mostly residential, small commercial. We're finding that optimizing ventilation in multifamily, it's a philosophical choice between, or a pragmatic choice and philosophical choice between rooftop units that serve the entire building and have to overcome stack effect, or individual units where individual maintenance is a little more involved because you have to get
Right.
into the units.
So, I think what you mean there is if we're designing a building and the building has multiple units, there are
Mhm.
different options for how we get ventilation air to them. And one of them is one large unit on the roof or a series of large units, depending on how big they are, all that serve the entire building, or having individual units in each apartment, say. And that's another option. And if you're going to have 35 apartments and each one has an individual Zehnder unit, that's going to increase maintenance because then you have 50 filters that need to be changed out, etc.
That's right. That's exactly right, which might cause somebody to say, well, why would I bother doing that? But it turns out that stack effect can really wreak havoc on a rooftop centralized building, a centralized ventilation system in a tall building in a cold climate. So individual units are the optimal way to do that, but other forces are at play that developers need to take into account. So property management is one of them, but generally the performance is spectacular of individual units that serve one or a few apartments. So,
Yeah, and we've seen companies also coming up with in order to deal with that same stack effect in large buildings, we've seen
mhm.
companies come up with units that just do one floor,
Yep,
like the Ventacity and others. Um,
that's right.
but in general, and the experience that I have with Zehnder overall is with the individual one unit pieces, and so the my experience started about 11 years ago
Hmm.
when I did a deep energy retrofit, learned about Passive House Standard, became a Passive House consultant, and had a CA350 installed in my house. So
Hmm.
one of the things I would just want to mention to our viewers is Zehnder is a company, a European company that got most of its HRV technology by buying a company called Stork Air, right, which is a Dutch company, which is another tie-in that I have. I happen to remember Stork Air, and I had a friend who worked there when he found out that I was doing Zehnder. He was like, "Hey, I used to work for Stork Air."
Hmm.
Um,
Hmm.
uh, so, uh, so reason I bring that up is because the CA350 that doesn't mean much to an American, but if you talk to a European designer, that's how many cubic meters per hour these units handle, right? Isn't that's the metric?
That's right. It's the metric way of describing airflow. And so like many companies, even here in North America, the model number often relates to the maximum capacity. I will say that some people presume that that is the ventilation rate that should be used in a house and make the selection incorrectly based on that number. You really don't want to run an ERV continuously or HRV continuously at that maximum speed because you're not going to get the maximum thermal recovery efficiency. You're not going to get the optimal moisture recovery efficiency. The electric consumption per CFM or per cubic meter per hour is not optimized, and wear and tear and noise become issues.
Right.
So just like a car, you don't get very good fuel economy in city driving. You think you might get good fuel economy at very high speeds because highway mileage seems to be higher than city driving, but the effect of friction on the movement through air or moving air through pipes is not proportional to fan speed. So if you double fan speed, you much more than double friction. So as a result, the sweet spot for ventilation systems is somewhere around 60%, maybe 65% if you're running it continuously. Of course, there are some people who put it on a timer relay and run at maximum capacity for small amounts of time to create an overall ventilation effect. But that doesn't necessarily respond to when there's a high pollution event, for lack of a better term. So continuous is sort of our MO.
Right. And in general, when I'm designing passive houses or houses that require mechanical ventilation for hygienic air, I always you always oversize the unit based on the fact that you want it to be running somewhere around 70%, right? 65 to 75%.
So that's right, but I wouldn't use the word oversized because some people who equate ventilation systems with heating systems know that oversizing is a no-no because of short cycling in heating systems. If those run on and off too quickly, you're never getting steady state efficiency. There is no problem with oversizing an ERV, even if somebody gave you a 500 CFM unit and you only need 100 CFM,
right. Because there's
you're
no
just
turn
using
down
less fan
ratios
energy.
for it. Yeah.
That's right. That's exactly right.
And the efficiencies, we've spoken about this on our show before with our viewers. Heat exchangers do better the longer the fluid is in contact with both sides of the heat exchanger. Right? You have a membrane of some kind, and it's either letting heat through or heat and moisture. And the longer those two streams are in contact, the better the efficiencies are. So the faster we're sending air through this thing, the lower the efficiencies are going to be.
That's right, Chris. And the analogy I use, and I appreciate you using the word fluid, although I rarely use that with customers, but you're exactly right, because air is a fluid. But the analogy I use is shaking somebody's hand who comes in from the cold. The longer you hold that person's hand and shake their hand, the more thermal energy gets transferred from the warmer body to the cooler body.
Oh, I like that.
So
I'll keep that in mind next time I'm
yep.
explaining it.
Yep.
So, yeah, I'm a huge fan of Zehnder. I personally, when I redid my house, one of the things that was a huge attraction to me was not just the high efficiency on the core, because the sensible recovery efficiency of the HRV and the ERVs are quite high, but also the ease of installation. I mean, the plug and play using the Comfo tubes and the plenums and the plug-in, and I mean, and mine was a retrofit, so I had a tuck under garage that was completely unframed and had no drywall, allowing me a lot of opportunity to make chases that I could send stuff and then up through closet walls and things. And the Zehnder system was just perfect, and it's really kind of a plug and play. You have 12 to 15 CFM per tube. You need 36 CFM. You do 3 tubes. You put a diffuser that accepts the 3 tubes, and you're done. They're all home runs back to a central plenum, so there's no duct sizing, which is one of the things I really like about the system as well.
Yeah. It is important to note, I agree, retrofits, no matter whether you're doing a traditional trunk and branch system or the home run system that we use, there's going to be some disruption in a retrofit where it's already finished and you've got drywall on studs and ceilings. The fact that it's 3-inch tubing and can snake through a stud wall, provided you don't have wiring going across that stud
or back
bay,
plastering or some other.
Yep. So there's a big advantage to that. I do want to try to eliminate the mistaken, what's the word, for the cliche that, well, you have to have a passive house to warrant mechanical ventilation. Don't really think that's true. It may not be the right move to only get mechanical ventilation with heat recovery when you have an inefficient house. You probably should do some air sealing to save some energy and improve on comfort before that. But bath fans, while a much cheaper option, waste energy because there's no heat recovery, and they have no impact on the indoor air quality of most distant or any sleeping area nearby, because you're not delivering fresh filtered air there.
I would even counter and say, because the the source of that air is uncontrolled,
Mm.
Jim and I often talk about pulling air through a cavity filled with fiberglass that mice are living in. So the
Yeah.
indoor air quality,
Yeah.
there's no question that having a bath fan on is not going to increase the indoor air quality of your bedrooms with the door closed or anything like that.
Yep. That's right.
But just to throw that out there, we don't like sucking through the muck, as Joe Strubrick once
Yeah.
once
Yeah.
said.
Exactly. And I would point your Vermont listeners, or any listeners really in the internet age, to some studies that have been done by Brian Just from Vermont Energy Investment Corporation. He did a study of 22 Vermont homes, some of which had no ventilation, some of which relied on windows for ventilation, some of which relied on bathroom fans for ventilation, and some that had whole house ventilation with heat recovery, to see what happened when doors were shut in sleeping rooms to carbon dioxide levels. And in some cases, I believe the numbers were way over 3,000, maybe even 4,000 parts per
Yeah,
million,
yeah.
which is a problem. So you look up Brian Just, VEIC, CO2 study, you'll find that information available. And it's a really concise report and very well done. So it's a
Yeah, well,
big...
fortunately, not surprisingly, my house was one of the houses that was a part of the
ah,
study, and my house had the best indoor air quality of all the
uh,
houses. And we cite that study on the show all the time.
yeah, okay.
And I'm a big fan of doing that kind of work, right?
Yep.
Actually finding out what's happening in someone's house. As a matter of fact, both Jim and I are big fans of the Air Visual Pro. This is a small unit that you can put in your house and move around.
Mm.
And we've been doing independent indoor air quality studies with that. And so what we've been able to show just with the 5 or 6 houses that we've done this on is that some of these bedrooms, when you close the door at night, are up in the 4,000 parts per million of carbon dioxide,
Yeah.
which in the end is not dangerous because you open the door, you bring the fresh air in, but it can reduce comfort, it can cause drowsiness, it can cause all kinds of very limited and recuperable, but definitely cognitive issues.
Yep.
So we want our indoor air quality to be good. I was looking a while back at the basis for the assumption that any house that's tighter than 2 air changes per hour at 50 pascals should have mechanical ventilation and should, in my opinion, have a balanced mechanical ventilation system. And what I found was that the standard that was used to come up with that has a lot of very loose numbers.
Mm-hmm.
There's like
Mm-hmm.
these bands across the country of these factors that you're supposed to put in, and all of Vermont is one factor that is supposed to go into that. And in the end, I was finding that even with 3 air changes per hour, there are a number of situations where if you're trying to keep your indoor air quality in good shape, that actually automatically designing and putting in recovery ventilation, balanced ventilation of some kind, either heat or enthalpy, is a good idea. And
Mm-hmm.
one of the things we've been finding, which is a bit disturbing, is crews are now getting really excited about getting a very airtight envelope, which is great. Let's make the houses very tight. But
Mm-hmm.
unfortunately, sometimes the builder is not looking at the fact that they've gotten the house so tight that they've passed the threshold and they should be introducing balanced mechanical ventilation, and they're not. We did a
Mm-hmm.
house about a year ago where the builder was like, "Yoo-hoo, we hit a 1.3 ACH 50," and I was like, "Do you have balanced ventilation on this?" No, no, no.
Mm-hmm.
I'm like, "Well, that's a problem." You're going to have
Mm-hmm.
some indoor. It's going to be stuffy. You're going to have hot, indoor air quality issues, and so that brings me. That's going to segue me into retrofits and new builds, right? Because although I was able to install the Zehnder CA350 and the plenums and the tubes and diffusers myself, Zehnder did put together and has a unit that's specifically a small unit that just goes through the wall and plugs in and can just work. That's the CA70. Tell me a little about the 3 basic models that you guys offer as far as ventilation rates, and then I want to talk about the difference between the CA and the new Q series.
Not sure what you mean by three separate models. Do you mean the CA70, the regular
Yep.
ComfortWares, and the Qs? Okay.
Yeah.
So the ComfortWare 70 was developed for the retrofit market in Europe. I will say typically exterior walls in European buildings, because more often you'll see masonry, exterior insulation, and exterior stucco. The wall assembly is a lot thicker. And that cylinder that goes through the exterior wall is where the guts, the heat exchanger is not there, but the fans that bring in air and expel air are in that assembly. So you need an 11-inch wall cavity to do that. But beyond that, the heat exchanger is inside the thermal envelope, and it is a sort of spot ventilation system that both supplies out of one side of the machine and returns out of the other. It's really designed to be at about 30 CFM. You can boost up to about 40 CFM. That's going to effectively ventilate a large interior space, but not many interior spaces.
Yeah, like one
it's got,
or maybe 1.5, right?
it could do two spaces, and it's been designed with knockouts on the side so that you can run a 3-inch duct from the unit to another space. So you could exhaust a bathroom at 25 CFM and supply an adjacent room at 25 CFM. And I've done that with some basement apartments, and that's very effective. And it's quiet, and it's not obtrusive, and you don't have to rip any drywall off to install it. You just have to make sure you keep your thermal enclosure and all the enclosures sacrosanct and tie
Air
it together
sealing, water, dampness, the whole bulk water,
Exactly.
and all that. When you're making a hole in the wall, whatever it
Yes.
is,
Yeah.
please make sure that you're dealing with bulk water and vapor drive and all the different building science forces that will be
Exactly.
acting on it.
Exactly.
Jim actually was one of the first Vermonters to have that unit installed in his house, and is a big proponent. And his main point is, just like you said, he's got a 2x6 wall. He's got 12 inches of this thing. He had to build a box outside to finish the run because of the way the sensors and other things
Yep.
work.
That's right.
Yeah.
Yep. Yep.
So that's the retrofit, and that's a great unit. And I think now I'm going to throw a number out there, and you can shoot it down. But I think that retails for about $1,700.
No, it lists for about $1,200.
Oh, 1,200. Oh, well,
Yeah.
then the
Yeah.
price came down from what I remember. That's great.
Yep.
That's great.
Yep. So, and there is a contractor discount when we prepare a quote for builders. We will take 10% off of that, and
then there's the Chris West discount.
that's right, which we can't discuss in this interview
nudge,
because
nudge.
It's so deep that we can't.
Ooh, that's
Yeah.
what put in the special code.
Yeah.
So so we've got the CA70, and the CA70 is a great unit for retrofits. It is in the market to be competing with small units like the Lunos, and it does very well in that market. The next step up is the CA or the 350 line, because there's the Comfo Air, and then there's the new Q series, right?
Yep. I wouldn't necessarily broadly categorize our stuff in three different ways. There's the Q, which is a whole separate family of things with different controls, higher efficiency, web capability, modulating bypass, modulating preheater. It's really like the state of the art of ventilation equipment right now. It's tough to sort of say our lesser model, because even our lesser model, the non-Q ComfortWare Classic series, still has amazing performance. And I'm of a mind where you don't necessarily need Wi-Fi capability in a ventilation system.
Yeah.
Just like, set it up, get it running, and then forget about it. And if
Yeah.
you have a boost switch in your bathroom, that's great. That said, the app isn't just a spare controller for the Q series. It also does calculations based on measuring all four of the airstreams about how many BTUs per hour per year you will save over time by using heat recovery. So avoided heating or an avoided cooling is a pretty interesting thing to know, because a lot of people say, why am I going to spend so much on a Zehnder when it's more than another manufacturer? Well, you can calculate if you want to do those calculations, the heat loss calcs to figure that out. And if you live in an expensive energy area, it's a shorter return. So get back to your question, the CA70 through the wall, decentralized, it's its own thing. The rest of the comfort air units, the 160, the 200, the 350, and the 550, all operate with the same kind of controller. All can come in HRV and ERV versions and are more based on the Dutch models that Stork Air had made prior to Zehnder absorbing Stork Air into its portfolio of companies. And so they're awesome machines. They run quietly. And like you, I did a project and got a ComfortWare 350 for my home before I was a Zehnder employee. And that's what turned me on to how amazing these machines are. So when I did a house for myself in Rockport, Massachusetts, and it was going to be double stud walls, basically pretty good house, triple glazed windows, the R10, what's Joe's description of this? R5 windows, R10 under the slab, R20 below grade, R40 above grade, and R60 in the roof.
Yep.
I just basically abided by that. As a result, I hit 0.4 ACH by just riding the builder saying, make sure you tape everything properly and
ACH
let me take
50,
a look at things.
Sorry.
At ACH 50, yeah, I don't often do per square foot of shell, so yeah, so thank you.
Sure.
And hit a very, very good number. Now, so all of our units can provide great ventilation, but you have to decide how much of the house is being covered. And if it's a big house with a lot of bathrooms, you have to pick a larger unit. And as you said earlier, not so much oversize it, but pick a unit that can do the ventilation rate, whether it's the Passive House Institute rate or the ASHRAE rate or the International Mechanical rate at a medium speed.
Right.
Now,
the sweet spot of the motors and
exactly
the whole
exactly.
thing, right? The motors, the
Yeah.
the heat exchanger, etc.
That's right. That's right. And one of the interesting things about the machines is all of them come with 4 speeds. And those speeds are allocated. The highest speed is the boost mode. You can temporarily increase the speed of the machine when there's a high pollution event. Is this a family show? No. When there's a high pollution event. And then the speed beneath that is the one I used for designing to meet the local regulations, if there are any in your jurisdiction. Then there's 2 speeds below that. The lowest one is called away. There doesn't seem to make a whole lot of sense if you're away for 3 or 4 days and there's no CO2 being generated and no cooking and no showers to run the system at the same speed. You're presuming occupancy generates moisture, generates CO2, and so a lower speed, and it's not off, it's about 15% of capacity, will keep VOCs that may be on construction products, formaldehydes in furniture, leftover pet dander that may be blowing around. So we always believe in ventilation, and the away mode will still provide ventilation even if nobody's there. Then that remaining speed in between the code one and the away one, I often find and suggest to customers that once you get in your house, once the moisture is all evaporated from your plaster and your concrete is cured, see if you can run the system at a lower speed and still have good indoor air quality. The boost speed still is the highest speed, but if you go back to a lower speed, your listeners already know that you'll increase the effectiveness, the heat transfer recovery, because the air is in the heat exchanger longer at a lower speed. So if you're still getting good IAQ, you save pennies on your electric bill, and you're still doing the job of ventilation. So, and it's quieter and preserves machine life. So it's great to have those 4 controls.
Yeah. So the 160, the 200, the 350, and the 550. Those are the steps,
Yep.
right?
Yep.
And at some point, I mean, I haven't done this yet, but at some point, I'm going to do a walkthrough on how Passive House looks at ventilation. The Passive House Institute US. There are basically 3 metrics we use. A third of the ventilation volume per hour, so you know the ventilation volume, the volume that's inside of the house, right? That's actually going to be moved by the air handler. And once you know the ventilation volume, if you know what a third of that is, that means that every 3 hours the entire indoor air has been refreshed, and that's one target, one possible target. Another target is the ASHRAE of 18 CFM per person. And the last one is the FIAS extraction ventilation, which is where we exhaust from moist areas at a certain rate. Kitchens are 36, bathrooms are 24, the laundry rooms and mud rooms are 12 CFM. So you just line those all up, and when you line those up, you balance those with supplies to the other rooms, your bedrooms, your living rooms, offices, etc. And with a family of 4, it ends up somewhere around 100 CFM, right? And you can look at the ASHRAE numbers, and that's almost always lower, and sometimes the third is higher. Finding that sweet spot for your space, but having those speeds, having that 100%, 77%, 57%, and the 15%, those four speed options, if I have those right, for the Zehnder, those are the options to ramp it down, like you were saying. If you're in your house and your indoor air quality is great, no reason to run it at speed 3. You can run it or at speed 2, which is that 77. Bring it down to speed 1, which is a 54, and see what your indoor air quality
I want to jump in and clarify something.
Yep.
That those percentages that you mentioned are not based on the capacity of the machine. They're based on the calculated rate of what of the ventilation standard. So the continuous rate that you come up with based on ASHRAE or FIAS or PHI or International Mechanical Road, that is a speed that you must comply with. In Passive House Institute, Germany, they limit the amount of boost such that that is 100% of what you're allowed to use for air movement through the space. And it has nothing to do with the machine. If somebody gives you an oversized unit, you're not using 100% of that unit. So those numbers, the 100, 77, and it's actually 54, I believe, not 77, are the proportions of 3 settings based on a calculated airflow. The middle one is usually the continuous flow rate, the higher one's the boost, and then there's a low speed for when you're away.
Right.
And sometimes people get caught up in 100% of fan speed. No, it's 100% of the flow calculation rate in boost mode. There often is much more capacity in an ERV than the equivalent of 100 over 77 of what the continuous flow rate is, and I hope I'm not losing people there with that.
No, I mean that's certainly deep in the material, but what on our show we like expanding people's understanding, and one of the ways you do that is expose them to new information. And when I go back, I may throw some graphics on to help people understand
That's a good idea, because graphically, people aren't necessarily always verbal learners. I know I'm not, so I'm trying not to talk with my hands so much, but
we're both talking with our hands.
Exactly.
I know we're all handsy.
Once you calculate that rate, and those 3 that you mentioned, 18 CFM per person and 12, 24, 36, and 0.3 air changes per hour, the highest of those is the one you're supposed to choose. And if it happens to be the 12, 24, 36, that's actually the boost mode. And so if your kitchen's at 36 CFM, and that is the 100% of what you're supposed to use, then the continuous mode is 77% of that, and the next lowest speed is 77% of that, which winds up being 54% of 100.
And what's really important is one of the things you get back when you do a FIAS project and you send in your ideas on what flow rates are, is that even at that 77%, that the rate at which you'll be having that machine on most of the time, you still have minimum rates. You still have to hit 28 CFM for a kitchen. You still have to hit 18 CFM for a bathroom. So there, even at that reduced rate, we do have minimums in order to make sure. And by we, I'm saying FIAS. I mean, I'm just a pacifist consultant. So the FIAS community, let's just say it that way.
Sure. And one also must be careful that local codes, if they have a higher rates than what FIAS or PHI allows, has to be superseded, which I'm not sure that a powder room that would have gotten 12 CFM in Germany, which is 20 cubic meters per hour, if going up from 12 that PHI would allow to 20 to meet an ASHRAE standard, I don't think that's going to blow your annual heating demands, but it might, and it's worth looking at. And
but that's when we're I'm a huge CA fan. I've been using the Comfort Airs for a very long time, and I'm with you on, I don't necessarily think that all of the bells and whistles of the new Q series are necessary for me personally, but it's not just that, because we also have a seriously improved ERV SRE efficiency, right? I mean, the CA is something like 76% efficient on the core, on the sensible recovery efficiency. But I saw numbers for the QR, for the ERV. I know the HR. Well, I can't do ERVs in Vermont, so they just seriously dry out the house in the wintertime.
should be the other way around, Chris. I mean, I don't know what your experience has been, and it varies based on how much moisture is dumped into the house. It isn't just a climate-based or geography-based thing, but I have seen people who insisted on HRVs and are cranking their air conditioning in the summertime, and the space that is being cooled, the surface temperatures are at or below dew point,
Ah,
meaning the supply registers in the room are chilled by the air conditioning that are around there. And I'm talking the ventilation supply registers.
right.
If those are at 68 degrees and the dew point temperature of the incoming air is 70 or 69 or 75, you are going to get condensation on those devices.
Yeah.
Maybe it doesn't happen enough, but I've seen it in coastal and humid conditions that's important. So I would challenge you to start considering ERVs, because since they do recover moisture, and moisture is precious, interior moisture is precious in the wintertime, especially in Vermont, cold climate, why would you want to expel all the moisture that you've generated? Now, it's not saying that you're going to preserve odors and cooking fumes and moisture from the shower, but some of that is going to be redirected back into the space, not with contaminants in it, but just the pure water
Right, after
vapor
going
molecules.
through the core. Yeah. No, I only do ERVs in my climate. I had an HRV the first year that we put the unit in, and we were so dried out in the winter. It was unbelievable. We were.
I think I misheard you then.
Yeah.
I may have misheard you or something. Sorry about that.
No, I'm an ERV in our climate guy. Definitely. I don't. I'm not only just because that's the general advice from the building science point of view, but I lived it. And in that first winter, the relative humidity was hovering around 20%, and we were all, with nosebleeds and itchy skin. It was really unpleasant. And I swapped it out, and nobody even thinks about it anymore. Yes, I'm not at 40% relative humidity in the winter here in Vermont. I'm at like 30, but boy, that 10% makes all the difference in the world.
Absolutely.
Yeah.
It's not the heat, it's the humidity.
Yeah, exactly. It's not the heat, it's the humidity. So, I was recently doing some modeling for a project, and they were speccing the new Q line. I think it was the Q600, which is comparable in airflow to the CA350, right? Do I have that right?
Nope, the 600 is almost twice as much.
So it is still related to that.
Same modeling ideas. And I didn't mean to speak ill of our Q series at all. They're amazing machines. And when I tell people that the ComfoAir Q350 has a sensible recovery effectiveness of 86% for the ERV,
which is amazing.
They almost don't believe me.
Yeah.
They almost don't believe me.
Yeah.
And so if you can recover 86% of the temperature difference, and by the way, that number is not the same at all fan speeds. It's kind of an average of a range among a range of fan speeds. So as you said earlier, lower the fan speed. If you still have good IAQ, you're probably ratcheting up the effectiveness, which is great.
Right.
So yeah, the Q is absolutely amazing. And aside from that, especially in a cold climate like yours, in wintertime, some manufacturers make machines that use an imbalanced strategy to protect the core from any freezing that might occur. So they ramp down the intake and keep the exhaust the same, so that exhaust is room temperature. The intake air is outdoor polar cold temperatures. You won't get as much frost. We don't believe in that. We believe in not depressurizing the building and always bringing fresh air, filtered air in. So you have to apply a little bit of electricity to that. Older models or non-CAQ models will pulse on a all or nothing electric resistance preheater that comes in the fresh air stream. It's not a space heater. It's to protect the core. The Q is smart enough in its logic and controls to know how much of its total capacity it should put into the incoming air, because it's also looking at the outgoing air and calculates the point at which frost in the recovery core could occur. And so there's a lot more sophisticated controls. And in that sense, I recommend them highly. They're great. And eventually probably we'll only have Qs down the road, but we still have a lot of demand for the slightly lesser priced regular ComfoAir Classic, we're calling it.
Right. Now, that was my point. I mean, like I said, I love the bells and whistles. I love the data collection. I love the increased efficiencies on the core, especially on the ERV side. I've just been taken to, during design phases, to accept an SRE of about 0.76 for the ComfoAir ERV core, and seeing an 86 or an 85% sensible recovery efficiency on the core for this new unit that's a game changer as far as efficiency. That's 10 points. And if you slow that down, you're saying, there is a curve. If you're into engineering, there's a curve that they have which shows at what speed that
That's right.
core is going to give you efficiency wise. And that
That's right.
is something that for the type of modeling that we're doing, the static modeling, which is usually good enough to get us really good information on how a building will act. We don't need to approximate that curve all that well. Just one SRE number is enough. But we're not doing that with heat pumps, right? With heat pumps, we're putting in the 47-degree COP, we're putting in the 17-degree COP, and then the program is saying, okay, that means that the efficiency curve is this, and based on the outside temperature, it's going to be able to be this efficient, use this much electricity. Similarly, maybe in the future, we'll see slightly better, numbers for tracking exactly what that is. And you're saying that the Q actually can tell you what the makeup air is that you're saving between outside air or just bringing
Yep.
outside air and
Yep.
and
So
going
it
to
does
the
that
core.
calculation based on, I believe it's just the heating saved. It doesn't, I think there's too many variables to calculate the pounds of grains of moisture and things
Right,
like that to
right,
do that
right.
calculation.
It's not going to deal with latent loads. It's going to be straight up just
Sensible loads,
yeah,
that's right.
yeah.
So, but what I like to tell customers who are sort of into this, but could easily get lost, is that in Vermont, if it's 10 degrees outside in the winter, a nice balmy January day of 10 degrees, and you keep it at 70 degrees indoors, just to make the math easy, you've got a delta T of 60 degrees.
Right.
If your efficiency is 80%, you're going to make up 8/10 of that difference. So that's what your supply temperature would be, except the preheater is going to influence that supply temperature by warming up the air coming in until it gets to about 24 degrees before it enters the core. So then you start doing the calculation of efficiency between that smaller delta T, your supply temperature is warmer. That's what remains to be heated by your heat pump or whatever your heat source is, or your solar gain. And those numbers are extraordinary when you have 86% recovery effectiveness.
Yeah,
It's
more
really
more
amazing.
amazing than
Yeah,
the 74 or 76%. That extra
far
10%
more,
is
far
gonna,
more.
because you're running that thing 24/7, and that's another bit. That brings me, interestingly enough, to the idea and the question about ground source preheaters, the Confo
Yep,
funds, which is another unit that I would have loved to have used at my house, but my
yep.
house is on ledge, so there's not enough depth to put PEX in the ground. So tell us a little bit about the Confo funds.
Sure. So in cold climates, the benefit of living in perhaps Burlington is that you have cultural access and it's a lovely place with views across the lake, but it's cold. And so you pay an energy penalty to live in a cold climate, no matter where it is. One of the ways to make sure your ventilation system doesn't freeze up when moisture is leaving the building and cold air is coming in is the resistance preheater I talked about earlier. Another way to do that, although it requires substantially more initial investment cost, is to lay a loop of conductive material, a tubing of some kind, well piping. Polyethylene well piping is just fine, that black stuff you use for well piping. And based on the conductivity of the soil, whether it's more clay than sand, based on the diameter of the tube, based on the airflow for the design of the project, we can come up with a proposal for a ground source heat exchanger that runs a loop of 50% glycol through a heat exchanger prior to getting to the ERV. And so it is powered, it gets the power from the machine, from the ERV, but it only uses a 20-watt pump to circulate that mixture throughout the
Closed
entire
circuit
loop.
pumps use very little energy too.
Exactly. And so as a result, the benefit you get of pre-warming winter air by using the temperature of the ground, which maybe is 45 degrees or 43 degrees in your neck of the woods, but the air is 10 degrees. So there is a benefit to doing some heat recovery and running that 20-watt pump. Now the air coming out of that ground loop heat exchanger has been brought up to temperature, a higher temperature, without using a lot of resistance electricity to do that. Then it enters the heat recovery device or the energy recovery device, and now your supply temperatures are coming in very close to room temperature. So in a bigger project that has the ability to either drill a well, if you're drilling a well any way for the house, you can run a loop down there. Or if you're doing a septic field, you can run it around the field. They do have to be apart from each other so that they can recharge and not rob Peter to pay Paul.
Right. You
So you
need
need
to
that.
not decrease the temperature of the ground.
That's right.
What I remember, just remind me, basically it was 300 feet of 1.25 inch PEX was what I was told back in the day, and they should be 12 inches apart. That was what the advice was
That
at the
would have been
time.
project specific, so I wouldn't say that that's the number to always use. And the last one I designed, it had to be 30 centimeters apart. This 12 inches minimum, but higher is better.
Yeah, the
More
more
distance
distance,
between them is
right.
better. Yeah,
As with anything, if you're pulling heat out of a system, that is not, you got to be able to give it the time to regenerate that heat.
that's right.
Speaking of that, I've heard some people talk about, continuing to use the compo funds in the summer to reduce moisture by dehumidifying the air. What's the skinny on that?
The skinny is that I try to tell people that it's not active dehumidification. There's no refrigerator coil. We're not compressing any refrigerant or anything like that. It's simply a liquid that doesn't freeze, but will transfer heat from the soil to the liquid. So if it's hot and humid and the glycol is at 55 degrees, then it's bound to extract some of the moisture across its heat exchanger that will drip out and drain away and thus cool and dry the air. But I want to be careful and make sure that people understand that it's not like a heat pump.
It's not like a
Yeah,
dehumidifier you have in your basement, but it does. It's kind of like the heat pump hot water heater. It's not a dehumidifier, but it has some dehumidification
that's
effect.
right.
Okay.
That's right. So if somebody came to me in Tallahassee, Florida or Louisiana and said, oh, I want to use a comfort fund to pre-chill and pre-dehumidify my house, I'd say, well, that's great. You're welcome to use that, but you better have a whole house dehumidification system because an ERV and a comfort fund are not going to meet all your humidity goals where 11 months of the year it's unbearable.
Right. But in my climate here in Vermont, part of what that will allow is if I've taken a lot of heat out of the ground during the winter cycle, I'll be able to put some heat back in the ground during the summer cycle because, we'll be bringing in the cold air, we'll be adding heat to it because the air is warmer. So that
Yeah,
we do the same thing when we design ground source heat pump systems that are closed loop, right? You want to be able to
yep.
make sure that you're not just taking heat out, but you're also adding heat depending on the season.
So that's why you shouldn't put your ground loop under your basement slab. It should be outdoors. And more specifically, I believe it needs to recharge because of solar gain. I don't think it's always recharging because of you can't rely on the annual temperature always being so warm as to recharge. In your climate, you're going to be taking out a lot more heat than you put back in, I
Yeah,
believe.
yeah,
And so, yes, it's good. You will get a cooling benefit. I don't think it's going to be as good as your heating benefit.
yeah. I think
The
that's
delta
probably
T's
true.
are just not the same.
Yeah,
So,
yeah.
yeah.
And it's like you said, it's so dependent on the ground geology, on groundwater moving through, if the pipes are in the groundwater or not.
Yeah,
There's a lot there, and those things can change every 5 feet, in on a location. So
yeah, yeah.
that's so. Getting towards the end of the interview, I think that I love the Q line. I'm really excited about seeing one in action. I think my CA 350 is probably going to be doing service for another 20, 30 years
Yeah,
before,
yeah.
and I won't be around to see when it needs to be replaced. And maybe by that time we'll be on from Q into another letter of the alphabet on the efficiencies. But I once again I've always been a big fan of Zehnder. It's the basic unit that I recommend for people. And on that, you brought that up for just a moment. The other manufacturers that first of all don't have the cross counterflow core, right? They only have
Hmm, hmm.
a cross flow core, the little square ones, and they add two in a row. That the manufacturers do use a core defrost, which is recycling the inside air. which reduces the flows. So if you're designing with one of these other units that does have a process where it defrosts the core by recirculating indoor air, that can be as much as a half hour in an hour if the core is badly frozen. So at that time, you're getting 50% of the outdoor air that you were expecting to get. And that's one of the reasons that I've always been less interested in using those models. Although they have a place, they're significantly cheaper to make. But when we're dealing with indoor air quality, personally, I want to go with a unit that I have a lot of experience with and a lot of confidence in. And in the end, Peter Schneider did a study years ago. The energy it took to run the COMFO funds on one house and the resistance electric on the CA350 specifically. It doesn't have that wonderful Q model modulation thing going on. It's just pretty stupid machine in that way. But what he found was that the COMFO funds used with the pump energy and the fan coil energy, it used about the same, slightly less energy than the resistance heater. But did have the added benefit of increasing the incoming air to a higher temperature. So your delta T's are lower. There's a lot in there, of course, but
yeah, he must have compared that to the avoided heating to figure out what the net of that was. That's interesting. I'm guessing that the 1.2 kilowatts of power that can be pumped into the airstream with the electric resistance preheater might just generate more saved energy and thus a higher supply temperature than the COMFO fund. But I'd like to see those numbers. I haven't
my
seen that,
experiences from what he was showing, it was the opposite. The COMFO funds was using less energy, but that in the end it was something like $100 a year to run the COMFO funds and $140 a year to run the resistance electric. The amount difference was not significant enough for him to say, "Wow, every house should have a COMFO funds," and that was really
and it's disruptive. You certainly can't do it in dense neighborhoods because you need a lot of surface area to do that. And if you have town water, you can't do that. Yeah, if electricity, if you're generating, if you have solar and you can fit it into your load and can calculate your heating degree days below 23 degrees, which are probably substantial in Vermont, then you could actually start to make a case for, well, maybe the resistance heater, even though it uses a lot more power at any given one time, you can afford it because the sun is powering it. So that's where I'd like to head, actually.
Great.
So
yeah. Well, I'm actually getting solar panels installed next month, so going net zero took a number of years to get it going, but we'll be there.
Great.
So,
Congrats.
John, if someone is interested in knowing more about Zehnder units and Zehnder products, what's the best way to get in touch with Zehnder? Are you the person they should reach out to? How would you like for people to interact with Zehnder America?
Yep. So if this was 2014 when we first met at Better Buildings by Design or wherever we met back then, I would say, yeah, sure. But we've grown substantially. And so we get a lot more quotes across North America. And I might be assisted by some of my colleagues in our office in New Hampshire to do the quotes. But somebody who wants to initially reach out, certainly you can do that through our website, ZehnderAmerica.com. Make sure you spell Zehnder correctly, Zehnder. My email is john.rockwell@Zehnder America. You'll find our phone numbers there, and I will do a design for you. If you provide PDFs of a project for me, I will do a design for your needs that meets whatever criteria you want. If you don't say anything about the codes, I just make sure that it meets the local codes. If it's a specific passive house project, I'd like to get the flow rates based on the treated floor area and ventilation volume as you've described earlier. So that's what you provide to us, Chris. But yeah, that's the way to reach out to us. And I do lunch and learns at architecture offices now that hopefully COVID is going to subside and the Delta variant won't take over. But love to get out and do outreach to engineering firms and architecture offices. More engineering firms is great, especially for multifamily, because they're the ones that are decision makers about speccing the products. But and there's lots of resources on our website with little videos and things about how to do things. So that's how you reach out.
Perfect. Well, John, thank you so much for taking time out of your busy life to spend 45 minutes chatting with me about heat recovery ventilation and enthalpy recovery ventilation and the the Zehnder line. And I assume that you're going to be at the Passfaus Conference in Tarrytown in October.
Currently scheduled to be there. Got the hotel room booked. We've got a booth set up. We'll see how they fare with the Delta variant. But
Yeah.
I appreciate, Chris, you asking me to do this. And it's nice to connect with you again. And we've had good conversations about building science. And I hope we can have more of them in person.
Well, the House Calls Vermont is going to have a booth. We're going to be doing live interviews there, so I'll probably do a walk around at some point, and we'll
Great.
chat some more. And we didn't
Good
even
again.
get to talk about both of our love of singing. So at some point
Oh, yeah.
we'll talk
Yeah.
about that.
I've got a gig tonight
Oh,
in 2
cool.
hours, 3 hours. Yeah. Yeah.
Well,
So
have some tea with lemon or whatever it is that you do for getting your voice ready,
will do.
and we'll be in touch at some point in the future. Thank you so much, John.
You're welcome, Chris. Thanks.
Okay.